NASA's live stream abruptly ended just as viewers claimed to witness the moon shrinking in real time. Rather than dismissing this as a wild conspiracy, it's worth exploring the broader context behind such claims, which actually connect to verified NASA research most people haven't heard about. While mainstream attention remained fixed on Mars missions and orbiting labs, NASA quietly published findings that confirm an astonishing fact: the moon is contracting. This isn't a future possibility. It's an ongoing event observable today. Recently, several viewers noticed visible changes to the moon's outline during NASA's live broadcasts, which were then suddenly cut off. Was this simply a glitch, coincidence, or something more? Investigating the science behind these incidents reveals far more intriguing details than any conspiracy theory. Using Apollo-era seismic records and advanced mapping technology, a 2024 study focused on the lunar South Pole, the very site planned for the Artemis crew landing. What scientists found was remarkable. Moonquakes are still happening, and these aren't gentle shakes. Some quakes reach magnitude 5, capable of destabilizing equipment, cracking future human habitats, and impacting sensitive broadcasting hardware. To make matters more concerning, one of the strongest moonquakes ever measured occurred near the South Pole, directly within the region targeted for constructing a long-term lunar base. Consider the scenario. A camera placed in this area might record a sudden shift of the lunar horizon, a trembling image, equipment moving unexpectedly, and in response, NASA terminating the live feed. This would be a logical step to prevent the world from witnessing an unfolding incident. The explanation goes deeper. Such seismic events are occurring because the moon's interior continues to cool and shrink. Every year, its diameter decreases by around 0.02 millimeters, generating significant stress in its crust. This tension leads to new fault lines and surface cracks, which could unexpectedly collapse, even while cameras are rolling. From the perspective of a live feed, a sudden surface drop could make it seem as if the moon was physically shrinking in that localized spot. Seismic modeling of the lunar interior suggests there is still a partially molten zone about 300 to 500 kilometers below the surface. If this layer shifts or compresses, the ground above might drop noticeably, not over geological time, but potentially within minutes or hours. Such rapid change, if occurring under a camera's lens, would visually resemble the moon's surface shrinking. NASA's seismic experiments reveal a moon that's surprisingly active. Newly formed surface cracks emerged after Apollo missions concluded, demonstrating that lunar reshaping is happening now. Add to that the moon's patchwork of magnetic anomalies, regions with intense localized magnetic fields, unlike Earth's global magnetic shield. These magnetic hotspots align closely with the same fault lines associated with moonquakes and lunar contraction. When rocks underground fracture under pressure, they release electric charges, and with magnetic anomalies present, researchers believe these events can produce electromagnetic surges strong enough to disrupt radio waves and damage broadcasting equipment. This brings a new perspective to those sudden drops in NASA's lunar live feeds. Signal loss isn't always caused by satellite problems. It could be powerful electromagnetic bursts caused by seismic activity on the moon itself, interfering with transmission and leaving viewers asking questions. When the magnetic field changes, camera feeds distort, making the moon's image appear to fluctuate or shrink. An intense electromagnetic burst then strikes, and the broadcast ends abruptly. This raises the classic debate: was it NASA's decision, or did lunar forces terminate the transmission? Consider sharing your perspective before diving into more revelations. The connection to Apollo remains compelling. Unexplained silence has accompanied lunar anomalies before, such as July 20th, 1969. As Apollo 11 descended, Neil Armstrong and Buzz Aldrin were seconds from making history when for 2 minutes, all radio contact vanished. No official explanation was published. While conspiracy theories emerged, later research indicated something might have happened beneath the lander's feet. Geological maps now show the Apollo 11 landing spot sits atop ancient thrust faults, the same crack systems still generating moonquakes today. The ground could have moved as Armstrong and Aldrin approached, potentially triggering an electromagnetic surge that briefly disabled their communications. Seismic records from Apollo's landing reveal odd vibrations timed with touchdown, though only decades later were these phenomena scrutinized. This leads to a far-reaching implication. Artemis missions are heading for the lunar South Pole, where the strongest, most recent moonquakes have been measured. If Apollo encountered unexpected interference in a relatively stable zone. Artemis could face even greater seismic risks in the most active area yet. This time, millions will be watching live in high definition. Should lunar tremors start during broadcast, distorting the surface, shuttering equipment, NASA would have to decide whether to share moments of peril or silence the transmission and address speculation afterward. The electromagnetic evidence becomes more intriguing with current theories about gravitational resonance. Modern physicists are studying whether shrinking lunar mass could subtly influence the Earth-Moon gravitational equilibrium. The Moon controls terrestrial tides with its gravity. Even minor changes in the Moon's internal structure could, in theory, create delicate ripples through the gravitational field. Some believe these micro-shifts could cascade into terrestrial tides, affect crustal stress, and alter atmospheric pressure. The concept borders on science fiction, yet gravitational pulses are taken seriously by some researchers. If a severe moonquake coincided with lunar contraction, it could theoretically emit a gravitational pulse. In such a case, NASA might halt the live feed as a precaution. Consider that Earth-based gravitational wave detectors like LIGO have picked up signals from events billions of light-years away. If a sudden lunar mass shift sent a ripple, those detectors could register the change even before telescopes and cameras did. Mission Control might instantly realize something extraordinary had occurred and opt to stop public transmission until experts could interpret the data. Should viewers ever glimpse the Moon's horizon pulsing, a visible space-time ripple, it would transform physics overnight. Layer by layer, these events could link electromagnetic surges, seismic movements, sudden feed disruptions, and even new frontiers in gravitational science. As for those who claim to have seen the Moon shrink, the truth results from a rare confluence of effects NASA never anticipated. But the actual science confirmed by NASA about lunar shrinkage is more sobering and unsettling than the wildest imaginations. Across the last 300 million years, the Moon's diameter has decreased by roughly 150 feet, like a grape slowly turning into a raisin, except it's made of solid rock. This slow contraction results in geological features known as lobate scarps, small cliff-like formations typically just a few kilometers long and up to 30 meters high. They're essentially wrinkles forming in the lunar crust. An extraordinary moment occurred in 1972 when Apollo 17 astronauts Eugene Cernan and Harrison Schmitt drove their rover directly over one of these scarps, unknowingly crossing a cliff formed by lunar shrinkage, the Lee-Lincoln Fault Scarp in the Taurus-Littrow Valley. Decades later, the Lunar Reconnaissance Orbiter captured images showing their rover tracks passing over this ancient scar. The process of lunar shrinkage is extraordinarily gradual, moving at about 0.02 millimeters per year, which equals the thickness of a human hair every 5 decades. Yet, the moonquakes this contraction produces are occurring now, in real time. Apollo-era seismometers documented more than 13,000 moonquakes from 1969 to 1977, many traced back to thrust faults. This means the Moon is not only shrinking, but actively cracking under the internal pressure. NASA orbiters have identified fault scarps that are so young. Geologically speaking, they formed after the youngest impact craters, highlighting just how recent some surface changes are. The upshot: Artemis astronauts won't be roaming on an ancient, stable landscape, but rather one that's still tectonically dynamic. So why do viewers sometimes think they've seen the Moon physically shrink during a live broadcast? Several technical explanations account for this, starting with changes in perspective. If a spacecraft moves away from the Moon, naturally it appears to get smaller. Alan Shepard, during Apollo 14, described seeing the Moon shrink through his window as the vehicle departed, fully aware of the cause. However, viewers may not realize the camera's rapid movement from the lunar surface, mistaking motion for actual contraction. Another scenario is occultation. When the Moon sets behind the Earth's horizon, as seen from the International Space Station, what's visible diminishes to a crescent before vanishing, which can look suspicious to those unfamiliar with orbital dynamics. Camera errors can further exaggerate this effect. Abrupt zooming may make the Moon instantly jump in size, and focusing issues might create a pulsing or fluctuating appearance. Compression artifacts caused by signal loss during live feeds from space add another layer of oddity, with frozen or misaligned pixels distorting or shrinking the lunar image unpredictably. The explanation grows even more disconcerting when considering actual seismic activity occurring at the same time as technical glitches. A moonquake generating electromagnetic interference combined with a camera malfunction could result in bewildering real-time visuals. This represents NASA's biggest challenge, a live broadcast showing something seemingly impossible to millions of viewers with no easy explanation. Analysis of these incidents reveals that NASA's feed interruptions usually occur exactly when something uncanny appears on screen, and as the lunar environment remains active, these coincidences are increasingly difficult to brush aside. When all elements connect, the moon's steady contraction, magnitude 5 moonquakes, nearby electromagnetic anomalies disrupting transmissions, and potential gravitational pulses detected on Earth, the situation becomes truly extraordinary. Add live cameras and instantaneous global broadcasts, and the stakes grow. During one of these lunar events, audiences may not witness NASA hiding extraterrestrial secrets, but rather the raw, astonishing reality. The moon is not merely shrinking, but remains very much alive, crackling with seismic and electromagnetic energy. Each broadcast from the lunar surface is a window into a world constantly threatened by tectonic and technological upheaval. The shrinkage generates pressure. Pressure causes quakes. Quakes lead to interference. As Artemis returns to the moon's most turbulent region armed with advanced cameras and communications, the question looms: what happens when a powerful moonquake interrupts a live broadcast, scrambling signals as the landscape shifts before the cameras? That's the real mystery. Not whether the moon is shrinking, but whether we'll witness these events as they happen before the stream ends. NASA Mission Control will have to decide in a moment whether to continue broadcasting or halt the feed to safeguard both astronauts and public understanding. When millions saw what looked like the moon shrinking, the event may have been the result of a rare combination: technical glitches, electromagnetic surges, and real seismic activity converging. The most chilling thought remains: what if a feed captured an actual surface collapse, a landslide triggered by a moonquake, at the precise moment of a broadcast cut? This investigation reveals the deeper truth. NASA's interruptions aren't about covering up scandalous secrets, but reacting to extreme lunar forces capable of disrupting even the best technology. Every electromagnetic surge, tremor, or gravitational shift presents an opportunity for another unexplained loss of signal. The moon is not a lifeless artifact frozen in space. It's a dynamic and constantly changing world, capable of surprising us when least expected. Each time the familiar "Please Stand By" screen appears during a NASA lunar broadcast, remember that the cause may well be real activity on the moon, not simply technical difficulties. The Artemis missions will test the limits of our technology against these hidden lunar forces. With modern cameras and instruments roaming the surface, new and previously unimaginable lunar phenomena will certainly be recorded. The moon continues to shrink, fracture, and display electromagnetic complexity. The question isn't just what we'll see next, but whether the feed survives long enough for the world to witness it. The lunar story is only at its beginning, promising mysteries yet to be uncovered.